Good afternoon, everyone. Thank you for attending our Navigating PCB Supply Chain Challenges webinar. My name is Ryan Wood, the Content Marketing Manager here at Epic. Before we get started, I just want to let you all know that you'll be muted during the presentation. And for those of you who've attended our webinars in the past, you may notice a slight difference as GoToWebinar recently updated its interface. So if you do run into any issues, please let us know. If you do have any questions as we move through the webinar, please enter them into the questions panel, which is in the webinar control panel, and we'll try to get to them all at the end of the presentation. If we don't have time to go through all your questions, we will reply to you by email. Also, we'll record this webinar and post the recording and slides on our website and YouTube channel. Our presenter today is Kendall Paradise, president here at Epic Engineered Technologies. Kendall's family owned and operated Beaverbrook Circuits until its acquisition by Epic in 2002. A graduate of the University of Rhode Island, Kendall's primary focus began in accounting, which gave her an invaluable perspective on what it takes to operate successfully in a competitive environment. She later successfully oversaw the creation and implementation of new purchasing procedures, which form the basis for Epic's highly effective global logistics and supply chain management. Today, Kendall oversees Epic's customer service and planning teams and manages both our overseas and domestic production and quality teams. So now, without further ado, I'll pass it on over to Kendall.
Thank you, Ryan. Hi, everyone. My name is Kendall Paradise, and I am the president here at Epic Engineered Technologies. I'm going to be spending some time with you today talking about how we're going to be navigating our way through the current printed circuit board supply chain challenges. We're going to take a look at why laminates matter, the current shortages and root causes, along with the downstream impacts and short and long-term outcomes. So to take a moment to go quickly over the agenda for today, as I said, we're going to talk a bit about what laminates are and their role in manufacturing to understand the importance of what these shortages are. And then we're going to go through an overview of the shortages and root causes. Third, we're going to discuss how this impacts different departments within our organizations, specifically engineering and purchasing departments, as well as quality, product managers. And then we're going to look at the impact across all of our industries. Fourth, we're going to look at some projected outcomes of how long these supply chain challenges are going to last. And then lastly, we're going to recommend some actions that could be implemented today to potentially mitigate these challenges that we're facing. And then we're going to finish with a brief Q&A. So to get started, what is printed circuit board laminate and what is their role in printed circuit boards? To be short, printed circuit board laminate is the material that forms the non-conductive core of nearly every printed circuit board. Laminates are layers of fiberglass impregnated with resin, bonded, and then clad with copper. That substrate is what determines the board's mechanical strength, its electrical insulation, the thermal behavior, and ultimate signal integrity and reliability. Changing the laminate can change the function of the board if not done correctly. And that comes down to the key properties of the laminate. So let's take a little bit of a look at what those key properties are and how they matter in the construction. Firstly, the dielectric constant and loss. This is what impacts the impedance control and high frequency performance of the board. The thermal stability is expressed as the glass transition temperature, or TG, and it governs processing windows and long-term thermal reliability. Mechanical strength and moisture resistance influence warpage and through-hole integrity. And the flame retardancy ties to safety certifications. Design choices and manufacturing processes are built around these properties. So when we're changing an existing printed circuit board to new material, all of these things need to be taken into consideration. So let's review what some of the common types of laminate are, as later in the presentation, we're going to talk about different challenges for each one of these types. So we're going to start with FR4. FR4 is the workhorse laminate of the printed circuit board in the electronics world. It's cost-effective for consumer and industrial electronics, and until very recently has been extremely readily available, and the pricing was always consistent. Next to that is high TG laminate, which is used for high power or high frequency printed circuit boards. Copper-clad laminate, or CCL, are often used and specialized in high voltage printed circuit boards. Polyimide supports flexible and rigid flexible printed circuit boards, especially in the aerospace and military applications. PTFE or Teflon materials are chosen for RF or microwave applications because of the very low dielectric loss. Each of these materials has properties that are specific to different types of applications, and they each carry different trade-offs. The higher the performance of the material, the higher the pricing typically. And there are also trade-offs in how they react in terms of their thermal performance as well as their manufacturability. So looking at the landscape today when it comes to printed circuit board laminate, historically, Common Core FR4 and CCL had the shortest lead times and the most predictable pricing. Usually a push in pricing would come from increased cost of copper, and then it would even then it would still be pretty short-lived. This has created an environment where most printed circuit board manufacturers feel very comfortable ordering laminate with very short lead times. A lot of times, most people are ordering in a 5 to 10 day window. Since January of 2026, this has been changing very quickly. Laminate suppliers have issued 8 different price increases already this year, resulting in, to date, as of this morning, a 40% cost increase in the base material. Lead times have moved from 1 to 2 days from the laminate supplier to the PCB fabricator to, in many cases, over 140 days, depending on the type of core material. The speed that this is changing is breaking the current procurement models. The way that lead times have been pushed out, it's accelerated a lot faster than many people in the industry, I think, anticipated it. Sorry about that. So laminate suppliers are working off a historically low inventory. As I said, sorry about that. The laminate suppliers are working off of a historically low inventory. As the production started to change and the volume started to increase, I don't think anyone was really ready for how quickly their inventory would start to deplete. Normally, when a PCB fabricator would place an order, the material would be pulled out of inventory and shipped in 1 to 2 days. With the current inventory levels that we're operating at now, most orders are now being produced at time of order, which obviously pushes out your delivery time. However, due to demands, nothing's being put in inventory. So all of the product that's being fabricated at the laminate fabricators is being shipped directly to manufacturers. They don't have enough excess capacity to be replacing the inventory that they've now shipped out. Most material suppliers have moved to an allocation system with their PCB customers over the last 90 days. So what is an allocation system and how does that work? What happens is the laminate manufacturers will look at what your average buy has been every month for the last year. That average becomes your allocation. The idea behind this is to prevent overbuying and hoarding and allow for a more equal distribution of the materials. The reality is that many PCB suppliers can jump the line, so to speak, by offering either cash in advance payment for the raw materials or expedite payments of 2 to 3 times more than the material is worth to try and buy other people's allocations. While the allocation system is far from perfect, it does favor the larger PCB manufacturers. Unfortunately, over the last 15 to 20 days, many printed circuit board suppliers have been told that their allocations that they've been receiving will be cut by 50% because while the demand continues to grow and the capacity can't increase to support that. All right, so now we're going to take a look at why the shortages are occurring. On the demand side, we've seen an explosive growth in AI and data center hardware, and we will talk more about that shortly. We're also going to talk about the supply side where there are feedstock disruptions as well as capacity restraints. So let's jump into some of those details. While the primary pressure is coming from AI infrastructure and data center expansion, there are other reasons that this is happening, and we're going to talk about some of those first because I feel like the AI and the data center expansion get all the headlines. In April of 2026, there was a strike at the Jubal petrochemical complex that halted the production of high purity PPE resin. That facility accounts for 70% of the global PPE production. PPE is a crucial feedstock for most type of laminates. Local disruptions at this level can take years to correct and will cause ripples across the global supply chain. Other demand drivers include automotive electrification. EVs and hybrids require complex multi-layer printed circuit boards for power electronics, battery management, and ADAS systems. These boards often need specialty CCL materials. And as we all know, all of the automotive industry is moving towards more and more EV and hybrids, and many states have new laws mandating this. High performance computing, which includes AI accelerators and edge systems, consume HDI boards and IC substrates. These sectors are pulling significant specialty capacity and increasing the competition for raw materials. So now let's talk about AI. As we all hear, you can't turn on the news or open an app or read without hearing about either the pros and cons of AI in data centers. So let's talk about the impact specifically to our industry. AI in data centers need advanced computing, which drives high performance electronic devices. This increased computing power raises the demand for sophisticated PCs and therefore sophisticated printed circuit board laminates. At the same time, expansion of cloud and AI services means new data center buildouts and upgrades require more servers and network equipment, and therefore larger volumes of PCBs. When you look at the impact of AI on the printed circuit board supply chain, there are two trends that stand out: the miniaturization of printed circuit boards and complex components. Designers need thinner, more flexible laminates and multi-layer high-density interconnect boards. Along with that, they need higher thermal and electrical demands. AI systems run hotter and require materials with higher thermostability and electrical performance. For example, a high TG laminate. AI infrastructure consumes only premium materials, or mostly premium materials. Large AI servers, accelerator cards, and high-performance storage push the need to low-loss laminates, high-layer count HDI boards, thicker copper constructions, high-speed laminates, and ultra-low profile copper foil. Laminate manufacturers are prioritizing AI customers, which is amplifying the shortages for standard commercial and industrial materials. Regulatory pressure is also a factor, both in the locations of these new AI data centers, but also in terms of increasing laminate manufacturing capacity. Environmental rules are tightening across major manufacturing regions. Chemical producers now face strict controls on solvent emissions, wastewater treatment, hazardous chemical handling, and carbon emissions. These constraints limit production flexibility and capacity and amplify solution pressure for specialty materials. Let's bring all of these drivers together and take a look at the materials that are under the most strain. So which materials are impacted the most? Under the very high pressure, that is the low loss and ultra low profile copper, again, driven by AI. That is for their servers or accelerator cards. So that is what's under the most pressure in terms of where the shortages are, but it's also where all of the capacity is being directed. Under high pressure, a little bit less, but it's still running around that, probably 100 working day lead time, is heavy copper laminates. Anything over 2-ounce copper is now considered heavy copper. But if you're operating in the 3, 4, 5 or 6 ounce copper laminate area, that's going to be facing increasingly long lead times and very difficult to get. High frequency and specialty prepregs are also under the high pressure area. That's driven again by EV power electronics, 5G and radar, aerospace, and limited production capacity. Under moderate pressure is high TG, FR4, and polyamide. This is driven by automotive and flexible aerospace demand. However, this is changing very quickly. It's escalating a lot faster than I think a lot of people expected. 062 and 093 FR4 materials are quickly running out of inventory at laminate suppliers, and they're moving from the moderate pressure to the high pressure very fast, as well as low TG materials. Many printed circuit board manufacturers have opted to no longer stock any lower TG materials under 150 TG because they don't want to waste any of their allocation on products that they won't be able to use for everyone. There's also anything over 2-ounce copper is being pushed out, and we've seen from our supply base that it's anywhere up to 6 months that 2 to 3 and 4-ounce copper can be pushed out. Also, chem material is no longer widely available unless it's in stock at a printed circuit board manufacturer. That has become very difficult to get inventory on. Ventec also posted on their website in November of 2025, not only talking about these upcoming shortages, but they continue to update the changes to their production schedule via LinkedIn, reflecting all of these different types of material. So now we're going to focus on the supply drivers that are going into these challenges. The global CCL capacity utilization was reported at 92 to 95% in Q1 of this year by the Taiwan Printed Circuit Board Association. And that's important because if you're starting the year at 92 to 95%, it doesn't matter what your demand is. There's only so far you can grow. So now we're looking at building new production lines, and that typically takes 18 to 24 months and can cost upwards of $100 million per line. With lead times like that and costs like that, it becomes very obvious where the new production focus is going to be set up to run. Suppliers are prioritizing all of this new investment and all new and excess capacity into the highest margin laminates needed to support AI and EV development. This is going to continue to further impact lead time challenges, not only for those materials, but also for the standard grade laminates. It's also going to continue to create cost fluctuations as people try and outbid each other to get what material is available. Lastly, copper foil and glass fiber are being diverted to lithium battery production, which is choking the upstream supply. So these demand and supply drivers produce a range of downstream impacts across engineering, purchasing, and product management, and also quality teams in our organizations, as well as across all of our industries. And unfortunately, there's no one-size-fits-all fix to this solution. It would be really nice to be able to come on here and do a presentation about here's exactly how you can avoid having any of these laminate challenges. Unfortunately, that answer doesn't seem to exist as of yet. As Ryan alluded to in my introduction, I've spent almost 25 years in this industry, and I have never seen laminate lead time and pricing change as quickly as I have now. This is going to force our industry to reevaluate our design processes, as well as ensure that our internal departments are all aligned on the same goals. This is going to require engineering, quality, product management, and purchasing teams to all be working on the same priorities, because a lot of times, as we all know, we all have different goals, and trying to requalify or establish lead times for all of your different products, if everyone's not going in the same order, makes it even more challenging. So we want to look at some challenges for engineering teams specifically right now, because there's several risks that are going to be unique for them. The first is that low loss material changes require tight spec adherence. Even a small dielectric variation can cause impedance mismatches and timing skew. When you switch laminate, you can expect higher reject rates and low yields on first builds or reworks because of material incompatibilities. Resin type, glass weave, or copper foil thickness can alter dielectric behavior and manufacturing tolerances in etching, drilling, and plating. These can lead to delamination and poor solderability. Lastly, qualification cycles are long. Fabricators and OEMs typically will require full stack-up testing to confirm controlled impedance, signal integrity, and manufacturability. While there are certainly many lower technology PCB designs that can change from one brand of material to another, or move from a lower 130 to 150 TG to a 170 TG with no problems, the more complex the design and the more specific the material, the longer that qualification period can take. Procurement realities have changed over the last couple of months as this has continued to develop. And order early seems to be the battle cry we keep hearing, not only from suppliers who are asking for forecasts, but also customers trying to book ahead, right? This feels very much like pre-Chinese New Year when everyone's trying to book ahead and get their product on order early, which is great. The challenge there is again, this is very new and nothing I've ever seen in the industry before, is that many printed circuit board suppliers are not going to start purchase orders that are due out more than 4 to 6 weeks, which even though you've placed a purchase order, it could leave you exposed to pricing and lead time changes. Now, why would you make that change? A big part of the reason that change is happening is because as printed circuit board fabricators are ordering laminate, they are being now told that the cost of that laminate will be determined at the time it ships versus the time when the order is placed, because the pricing keeps increasing so fast. So what production facilities are doing is they're placing order, they're starting production on this stuff that they have laminate for, that's due in the soonest amount of time, because they have that cost already associated. So to guarantee pricing and lead time, you're often going to have to be ordering advanced amounts of inventory in a short lead time to get it regardless of when you're actually going to need it. Many factories in Asia do not offer stocking programs at all. So if you're trying to place an order today that's not due until October, you're going to want to have that due, the purchase order date you're going to want to have reflect in August, so that they can start it and ship it to you in August and then manage the inventory internally. Because like I said, many suppliers are focusing on only running what is currently due. Additionally, the quote validity window is continuing to shrink. If you look back to even as recently as 6 weeks ago, most quotes in our industry for circuit boards were good for at least 30 days, if not longer. And what we're seeing at this point is most have reduced down to about 3 to 5 working days. Additionally, there's an urgency for you to understand what stack-ups you're currently using and flag advanced laminates or unusual stack-ups, as these will not only have the longest qualification times if you have to change material, but they'll also have the longest lead times when you need to build them. And exploring alternative laminate options whenever available is always a good idea at this point. Looking across the industries, we can see where this impact is already being felt. In telecom and 5G, which has higher frequencies that require lower loss materials, they're competing directly with AI. So they're facing laminate shortages across the board. In the automotive industry, even small printed circuit board delays can shut down vehicle manufacturing, which is already a very complex supply chain that's being exposed to the end of the USMCA, which is going to already increase lead time and cost on its own. Automotive changes have long and expensive qualification cycles, which make changing materials time-consuming and difficult. In the medical industry, obviously there's strict, which we all want, there's strict regulatory compliance, and changing laminate requires extensive validation. The testing and documentation will delay production, regulatory approval, and new design rollouts. On the aerospace and defense side, these applications typically specify exact grades of laminate for high reliability reasons, and alternative materials can take months to qualify. Consumer devices often use standard FR4 material. However, smartphones, gaming hardware, and AR devices are increasingly requiring advanced materials. As FR4 becomes scarce, it will impact the larger volume production of many consumer goods. It's really hard to say for sure what the outcome of all of this is going to be. With how quickly the global supply chain is changing, the best thing that we can do is gather as much information as we can and make educated decisions, starting with a plan A, a plan B, a plan C, and so on. These are some of what we are anticipating in the short term and what structural shifts may follow in the medium to long term. This is obviously subject to change at any time. In the short term, which we're anticipating is 6 to 18 months, I think we can expect to see continued lead time extensions and allocation restrictions. I would anticipate that the allocation system will stay in place probably for closer to the next 18 to 24 months as capacity starts to come online to get suppliers back up to their previous inventory levels. Material costs will remain pressure tested as suppliers deplete what little inventory they have left, and geopolitical challenges keep driving raw material costs up. Allocation and quota systems will disadvantage smaller manufacturers who lack purchasing leverage to barter or increase their allocations. Production lead times will continue to be pushed because of this, especially when there are quality issues, as replacement material will most likely not be readily available. And as capacity continues to be allocated to high-end AI server sector, the availability of FR4 and CCL, especially over 2-layer, is going to continue to shrink. Looking out longer in the 18 to 36 month range, we're anticipating new laminate capacity, but again, it will be mostly focused on the high-end materials. We've already seen that from a lot of the supply chain. There will most likely end up being a consolidation of smaller PCB manufacturers as they're getting priced out of the material allocation. This is already starting to happen both here in the US and in mainland China. A lot of smaller manufacturers aren't able to pay the increased price with how fast the pricing is increasing, or they didn't have enough inventory on hand to be able to bridge that delta between the new lead time and the old. Overall, the procurement process will change again. Printed circuit boards have always been a short pole, with CMs, OEMs, and fabs waiting until longer lead time components, which are typically more expensive, are in-house to order printed circuit boards. This model is going to have to change as we're no longer able to count on standard materials being readily available. Industries will have to shift from a pure just-in-time model that we've seen today and gotten very used to towards more long-term contracts, strategic inventory programs, and close supplier partnerships that have measurable actions on both sides, be that volume of parts per order, cost increases, on-time delivery metrics. So some recommended possible actions. These are some tactical steps that we can take to ease some of the burden that can be implemented now. It is important to note, however, that when we're going to talk about qualifying alternate materials, there's still the same capacity issues that we're seeing from Isola, Shenyi, Nanya, Kingboard, Bentech, etc. What we're talking about is alternate smaller suppliers, but I want to make it clear that they are still hand-to-mouth with manufacturing as well. There is no, unfortunately for all of us, there is no miracle stock of inventory waiting somewhere. The idea behind talking about qualifying alternate materials is to allow us better exposure to more options and better the chance of having a shorter lead time. So managing the shortages. Multi-sourcing on 2 levels. Firstly, when we're talking about multi-sourcing, is for your high volume printed circuit boards, it's a good idea to evaluate having multiple printed circuit board fabricators who are qualified to build. Again, the idea is to increase your chance of maintaining current delivery schedules and not disrupting your production. One supplier may not be able to build 100,000 pieces of a printed circuit board, but they may be able to do 50 or 60, and your alternate supplier might be able to fill in the gaps. This way, you're cutting out the cost and increased material time. Having large volume part numbers that are sole source can lead to increased costs on your half, and again, extended material delivery times. The second part of multi-sourcing is on the material level, which is approving alternate stack-ups and getting in different material brands that will increase the leverage to get laminate quicker. Next, we want to look at strategic inventory when possible. This can be vendor stocking programs, managed inventory programs, bonded warehouses. I think a lot of people, as just-in-time became more popular and easier to manage within the electronic supply chain, a lot of companies and customers have moved away from these types of inventory programs. And I think partnering with someone who has the ability to not only build your product at the most cost-effective way, but also be able to manage that inventory is going to be extremely critical. Bonded warehouses are another great option where you'll be able to bring in inventory earlier and not have it affect your books as inventory. Because in order to secure today's costs, we're going to have to build longer lead time product today. Otherwise, as you move forward, there's too much flexibility in the cost. Something else we've looked at and talked about is negotiating long-term contracts with volume commitments to secure your allocation and cost. Working with your suppliers to, if we buy this much, the price will stay this regardless of what happens in the environment. Those kind of contracts, again, They were something 10, 15, 20 years ago were very common in our industry. And as our industry flattened out over the last 10 to 15 years, this type of relationship has gone away. And with all of these shortages, it looks like this is going to become a much more important part of our business once again. And lastly, accelerating qualification. Obviously, we're not talking about cutting corners, but starting to pre-certify alternatives and secure lab space and document your qualification plan today versus waiting until you place that order and the lead time comes back and you're told it's 4 to 6 months. Looking at what you have in front of you for the rest of the year in terms of your production and determining which parts are at the most risk. So we're gonna summarize this. Operationally, it's a really good idea to flag your critical programs and create a prioritized SKU list to get ahead of shortages. Aligning all of your interdepartments, engineering, procurement, product managers, and quality teams. This is especially difficult in this day and age, as a lot of those groups aren't even in the same building, let alone the same state. But getting on the same page to understand what your internal priorities are, what you can change and what you can't, and what the repercussions of all those changes are. Because you can't change every part number at once, and you're not going to need to change every single part number. When possible, in your design process, design for material flexibility. That could mean allowing for alternate stack-ups or relaxing non-critical tolerances that maintain performance and increase supply options. When possible, try and create a universal stack-up or material list across your parts to increase your material availability. So as we said, laminate is a critical choke point for the printed circuit board supply chain due to the demand surges, the limited specialized capacity, the upstream feedstock shortages, and logistic bottlenecks. AI data centers and EV growth are absorbing the majority of available capacity and will continue to do so for probably the next year. We're expecting short and medium-term extended lead times and pricing increases in printed circuit boards as the pricing is no longer stable. So at this point, I'm going to turn it back to Ryan really quick and go through some of the questions that you guys have sent in, and then I will be right back to answer those. Ryan?
Thanks, Kendall. Now, while Kendall reviews those questions that came in, I just want to briefly mention some of the additional products we offer here at Epic. For more than 70 years, Epic has designed and manufactured custom build-to-print electronics. Our expertise not only lies in printed circuit boards, but also in flex and rigid flex PCBs, battery packs, overmolded and other types of cable assemblies, CNC machining through our sister company Metalcraft Machining, high reliability user interfaces, flexible heaters, and energy efficient fans and motors. Next slide, please. Now I'll turn it back over to Kendall and she'll go through some of the questions that came in.
Great, thank you, Ryan. We definitely have some good questions here. So I'm going to jump in and start with this one. How do regulatory and environmental compliance contribute? Can you clarify that further? Absolutely. Compliance is things like REACH, RoHS, emissions limits. That forces producers to change chemistries, invest in abatement equipment, or stop non-compliant lines, all of which raise costs and create slower output. The bigger challenge is the stricter local environmental rules lengthen the timelines for capacity expansion. You can't just open a laminate manufacturing plant in a lot of the United States and a lot of Europe. They have very strict rules about this because of the wastewater, the emissions. So regulatory compliance plays a huge role in the amount of product you can build geographically. And that also further restricts quick growth. All right. Let's see. Can you talk more about single source suppliers on specialty laminates and the risk posed to PCB manufacturers and OEMs? Yes, we just touched upon that briefly, but single source reliance, it creates concentration risk, and any sort of supplier challenge, God forbid there's something that happens, in terms of a natural disaster. There was just a typhoon in Taiwan a couple of days ago that shut production down there for a couple of days. Those are things that can halt production downstream. but it also limits you to, when you're building a high volume part single sourced at a supplier, it limits you to whatever their purchasing restraints are. It also limits you to wherever you fall within their organization in terms of size of customer and priority to production line. And it could also expose you to greater risk of quality issues, because if they have contamination on a line, and it tends to lead to longer lead time spikes. Unfortunately, it could eventually lead to price gouging, especially in a market like this where the cost of laminate is changing every single day. But if you know you're the only source for something, that becomes much easier. And it also, it slows down alternative material qualification, because you're going to be at the mercy of whatever materials it is that they're buying. All right. All right. How might short-term supplier allocation practices by laminate affect smaller OEMs? Well, I think that this is something that we're definitely going to see happen, and we're already starting to see it happen. Suppliers, unfortunately, often prioritize large contracts or strategic customers during shortages, and that leaves smaller OEMs with delayed deliveries, if any at all, partial shipments, and larger price increases. As we talked about at the very beginning with the allocation system, the laminate suppliers have gone to about a 50% allocation rate. There are some small factories that have been told that their allocations, they don't even get 50%. They're going to get it every 2 months instead of every month. So the smaller that you are, it definitely makes it more challenging in terms of being able to stay on top of your production schedule. This, again, enforces production rescheduling, and it could create contract penalties and disrupt your customer relationships. All right, we have time for a couple more. All right, let's do, what metrics should procurement track to proactively detect and manage emerging laminate lead time risks? That's a really interesting question, because on-time delivery is obviously something everyone in our industry prides themselves on. And I think that that's definitely going to be something that is a little bit different as we move forward. So I think it's really important to look at your supplier lead time trends, how they're delivering, or the time frame in which they're delivering versus what we would traditionally consider on-time delivery. If you were getting your circuit boards in 25 days from your supplier, what does that look like this month, next month? Because it's going to continue to expand. Percentage of your spend at single sources, again, understanding what your leverage is with each of your suppliers and making sure that you're not exposed by having too much of a product with any one supplier. Looking at capacity utilization and backlog, pricing trends. Again, I think that this is unfortunately one of those times where price gouging is something that can happen on the laminate side, because the price is increasing so much. I think people just start to, I'll pay that to get material. So pricing trends is very important to keep your suppliers honest. And then internally, one of the big metrics is going to be your time to qualify alternative materials. Creating your own timelines of how long it should take to review a stack up or approve a different data sheet provided. Those are important metrics that we want to be able to look at and judge ourselves by, to make sure that we're doing everything correctly. All right. We have time for one more. So this is an interesting one. In what ways can design engineers modify circuit board designs to reduce dependence on scarce laminates? That's a challenging question to answer, because it feels like every hour that passes, the definition of scarce laminate grades grow. It feels like they're all scarce at this point, but we want to protect ourselves at the most that we can. So, from an engineering perspective, it's broadening material specifications, allowing for multiple acceptable DK, DEF, or TG ranges, looking at using alternate stack ups, substituting less specialized laminates where performance tolerates, Utilizing suppliers who offer DFM is a great way to do it also, to have them take a look at what you're working on. So there is a variety of ways to try and minimize it. But as we've said, I think that this is a global shortage that is going to impact everybody at least a little bit. So I want to thank everyone for their time today. That is unfortunately all the time we have for any additional questions, but any additional questions that we have in the chat, we're going to be, as Ryan said at the start, we're responding via email. So thank you, everybody. I hope you have a great day, and we look forward to hearing from you and working with you through these challenges.